Adding and subtracting complex numbers. Just like adding and subtracting regular binomials. If they're parentheses, see if there's anything you can distribute first. Once everything's distributed, the parentheses are dropped and you just combine like terms. And you treat the A's as like terms and you treat the BI's as like terms. So you'll always end up with a complex number. But if either an A or a B is 0, then you need to write that 0 as a placeholder if you're told to put the answer in A plus BI form. So here, I've got those canceled out because there was one positive, one negative. But because if we're told to put it in perfect BI form, that means that we have, because the i's canceled out, so technically the answer is just -9. You ended up with one negative I and one positive I when you distributed that negative sign. So they canceled out, but if you're asked to put it in formal notation, then you have to put a placeholder for that BI. There is no I, but a 0I means there's no BI, but we're writing it formally. Make sense? Okay. So as we're going to jump into multiplication, especially our special products, just like I sort of did with the radicals, let's add i's to the mix. So as quickly as possible, tackle these 10 situations, keeping your addition rules versus your multiplication rules straight. You've got just regular terms, radical terms, and i's. How do they get combined depending on multiplication or addition? Regular terms, radicals, and i's. Once you understand radicals and what a radical means and what an I means, it all gets back to the same basic rules that we use with regular terms. But the key thing is that rules for addition are different than rules for multiplication. Any big confusions here or This is the kind of thing that needs to, as you get more confident, as you practice, becomes the sort of thing you recognize in your sleep. What's my operation? It's going to send you in two different directions, whether it's addition versus multiplication. Of course, subtraction goes with the addition rules and division goes with the multiplication rules. Questions? Okay. All right. Let's jump into multiplication, especially our special products. Okay, so we just looked at addition and subtraction. Okay. And now this would sort of bridge us into, so addition and subtraction is all about combining like terms, distributing negatives, or distributing if we need to drop parentheses, and then just combining like terms, like here, but only if you have like terms. And now multiplication is about making combinations according to our exponent rules, radical rules, and I rules, which everything can be multiplied, but it might affect the outcome. You know, if you square a radical, it kills the radical. If you square an I, it kills the I. And if it's not the same thing, not the same radicand, your product rule still allows you to combine things. You can just take away the dot, you know, and combine them. You just can't smoosh them together any further. Okay. So, multiplying. Now we started off with multiplying radicals with negative radicands. Okay. So most of what we're looking at now with these examples don't involve negative radicands, they do involve i's, which came from the definition of square root of negative 1. Okay. So in 11.7, you're going to see a mix of just i's as well as radicals. Okay. And some of those radicals will have negative radicands, which you change to an I. Okay. And some don't, and you just still use your rules of radicals. So we're sort of combining all the rules together here. So multiplying, just multiplying basic terms, negative 7i times 3i. Just an I times an I, a pure imaginary times a pure imaginary. There is no radical with a negative radicand here to deal with. Remember, if you are involved in any problems like this, and you do have a radical sign that has a negative radicand, your very first job, regardless, is to change that, to pull out the I, so it's I radical positive radicand. Okay? So no radicals in this one. We are dealing with i's, but they're already i's. And this is all multiplication. All this means is negative 7 times I times 3 times I. Okay? So I'll expand it, even though as you get more confident, you won't need to do this. But the idea is that with multiplication, all multiplication, you're just multiplying things that go together. Okay? It's not as strict as like terms. Okay? But it's just things that go together. So of course the coefficients, the real number coefficients go together. And then we got an I times an I. Now negative 7 times 3. Okay. And then I times I.
Why do you have two? Oh, okay.
Yeah, because they both have i's. Yeah, so it's I times I.
Just 21, right?
Exactly. Because what this means is negative 21 times I squared is negative 1, which is equal to positive 21. Now recognizing I squared equals negative 1 means wherever you see an I squared, replace it with times negative 1. But also recognizing, hey, an I squared, if it equals negative 1, all I'm doing is flipping the sign. Okay? So as you get more confident, you'll see, oh, I squared, I can just cancel it out and flip the sign. So this was a negative 21, so it becomes positive 21. So I just cancel out the I squared and flip the sign. So, which of course then equals just positive 21. Either way, same answer. Okay. Distributing. Now just like distributing with regular terms, like if this were 3x times 2 minus x, I'm hoping you're at the point where you're confident enough to do distribution with just regular x's, mostly mentally, that you can immediately just write down the answer and mentally handle the multiplication of the x's and the numbers. That's an efficient thing to get to. But just like I encourage with radicals, I'm going to encourage with the i's. With i's and radicals, go ahead and write out that expanded step. It might seem like a little more work at first. It's going to save you work because it's going to save a lot of careless mistakes and a lot of confusion trying to sort things out. So take the time to write the expanded step. It's actually going to save you time and save you careless mistakes. Distribution, whether with regular terms, radicals, or i's, means 3i times 2 minus 3i times I. And I take the time to write that step just like I would with radicals, because the i's and the radicals can do some funky things, and you want to be straight about what you're looking at. So this is just a little multiplication packet. The real numbers get multiplied, 3 times 2, and there's a single I, so that's it, 6i. Just like it is 3x times 2, it becomes 6x. Minus 3 times I,
Which
All right. This becomes means minus 3 times negative 1, right? So I squared becomes negative 1. Since there's something else there, I can just cancel it out and change that negative to positive. Because it was negative 3 or minus 3, I just changed that to a plus. If this were plus, I'd throw a negative sign in front. I squared cancels out and throws and changes the sign because it's equal to negative 1. So this becomes 6I plus 3. Now, if we were dealing with x's, then it'd be 6x plus 3. We'd leave it, but we want it in complex number form, so how should I write it? Right. A plus bi. Okay. So do I times 5 plus 6i. Write out your expanded step. Simplify each little packet using your regular multiplication rules, in many ways treating I as if it were a variable. But whenever you end up with that I squared, unlike an x squared, an I squared actually cancels out and flips the sign.
do we have to like flip it like you did on that first one, like 3 plus 6i, or can it just be 6i?
No, because you're going to be asked to write it in A plus BI form.
So
Yes, so real number component first, imaginary component second.
and if in this case it's a negative in front,
Right.
you just leave it.
Yeah, even if it's it doesn't matter if your A is negative or positive, it doesn't matter. I know a lot of times, I don't want that leading negative. With regular variables, that's usually the case. If you can avoid a leading negative, that's great. With complex numbers, doesn't matter. It should be an A plus BI, whether your A is positive or negative. So that cancels out to negative 1, so I cancel it out and throw a negative out front. And so the I squared's gone, I'm left with a negative 6. That gets written first. That's my A, my pure real. And then that's a positive 5i, so plus 5i. And so to be really pure about it, because I think Math Lab actually is really picky. I wouldn't be as picky about, like, say, this first one, but Math Lab might be. Make sure you read the directions carefully. If it's asking for it in A plus BI form, then this answer, which was positive 21, how should that be written?
21 plus 0i.
Right. We're being really formal about it. So make sure and check the directions carefully. Okay, so either multiplying a term times a term or a term times a complex number. This is not a binomial. It's a complex number, but it behaves, our same rules, it behaves like a binomial as far as our patterns of multiplication. Okay? Which takes us into more our special products or other patterns of multiplication, such as foiling. 2 minus 5i is one complex number times 4 plus I. And first thing you want to notice is, what is the operation here?
Multiplication.
Right. If there were a plus sign in between these parentheses, you would just see if there's anything to distribute, drop the parentheses, combine like terms. This is not an addition problem, though. This is a multiplication problem. That's the first thing that needs to be checklist. Like, that's whenever you're doing homework and studying, note, because you're going to have some mixed up problems on the test. You'll say, do the indicated operation in the directions. And so first thing you have to do is, what is the operation before you can do it? Here, this is a multiplying a binomial, well, not a binomial, but a complex number times a complex number, which we will FOIL as if we were multiplying two binomials. And just like with radicals, go ahead, as much as I want you to, with regular terms, FOIL, more and more mentally. With radicals and with i's, go ahead and write out that FOILed step. And as I pointed out before, and especially with this I squared, I really encourage, again, my sign way of dealing with signs is to see whether it's going to be a plus or a minus, and then everything I write in parentheses is just positive. I take care of whether it's positive or negative by saying, oh, it's going to be plus or it's going to be minus. That way I don't actually get lost in my negative signs and get turned around. So this is just a positive 2 times a positive 4. And then my outside terms are both positive, so I put a plus sign. my inside terms, 1 negative, 1 positive, so I put a subtraction sign, and then I just put 5i and 4 in parentheses. Everything in parentheses, I put the positive version. I take care of whether it's positive or negative with the operation in front. My last term's 1 positive, 1 negative, so I just put a negative sign, a subtraction sign, and then just put 5i times I. Now, with FOIL, depending on whether you've got regular X terms or radical terms or I's, you start off with 4 little packets, FOIL. Okay? Now, when you're dealing with X's, that may stay 4 terms, or it might become a trinomial if you can combine your O plus your I. With radicals, same thing. It depends on what you can combine. If they both have radicals in the binomial, or only one of them does. With I's, you will have FOIL. It will always come down to 2 terms. It will always, a complex number times a complex number will equal a complex number. Okay? You'll end up with an A plus BI. Now, something might cancel out. You have to put in the 0 placeholder, but you're not going to have 3 or 4 terms. Okay? You will have 2. All right, so simplifying each one, that's 8 plus 2i minus 5 times 4, so 20i, not I squared, just 5 times I times 4, as if it was 5x times 4 would be 20x, then minus 5i squared. So first I deal with that I squared. Right. So the I squared cancels out, becomes negative 1, so negative 5 becomes positive 5. And I can combine now my numbers, 8 and positive 5, as well as combine my 2i and my negative 20i. Numbers first. I. Okay. So you do 6 minus I, 4 minus 3i. Do that pretty quickly. I want to make sure I cover the other topics. Okay. So try and be as quick and as efficient as you can. Know what your goal is, 4 terms, but then you know it's going to become 2. The F and the L will both be numbers that will make your pure A, and the O and the I will be imaginary terms that will combine to your BI. See, I'm still doing my same thing with the operations. For example, these are both minuses, so I see my L is a minus times a minus, so I know that's going to be a plus. So you see, I don't even write even negatives when I expand it out, because I know a minus times a minus gives me a plus. I just took care of the signs. And I just write the actual terms as pure positives. I took care of the sign, negative times negative is positive, by writing the operation of a plus sign. You don't have to do it this way, but I keep mentioning it and bringing it up because I find it keeps things the cleanest, avoids careless mistakes. So this was plus 3i squared, but became negative 3. Because the I squared canceled out and multiplied, changed the sign. Okay? Okay. So I'm barely ahead, but stop me if there are any questions. So I'm sure to cover all the topics that we did in my 8 a.m. so you can be sure and tackle all the homework. There's one little thing I know we won't get to. We'll start off with that on Thursday, but I want to give you as much to work with as possible before we break. Okay, so this next one, like foiling is a special product, so is binomial squared. A binomial times itself. Now I wrote binomials on purpose because these are like binomials, but these are not actually binomials. Okay, these are complex numbers squared, which we are going to treat as if they're binomials, using the same patterns. Okay. We're going to get the same pattern as if we were squaring a binomial. Now, a binomial squared, as much as possible, if there's no radicals and there's no complex numbers, as much as possible, I want you to be able to do this mentally. At this point, I want you to be really confident with the binomial times itself, not, like I said, not so much memorizing a formula as being able to sort of mentally foil it. Because what we do on Thursday is going to take this skill, and the more you can do it mentally, the easier time you're going to have it on Thursday. And I want you to be able to look at that and go, I know this is x plus 3 times x plus 3, but I'm not going to expand it out and foil it. I just know that means my first term is squared, and then, yeah, 3x doubled, which was, so it was AB doubled, 3x doubled, and then, and this middle term is plus or minus depending on that, and this last term is always positive because this is either 2 pluses or 2 minuses. And boom. Done without any, that's the mental process, okay? A squared plus 2AB plus B squared. Your first term squared plus your AB, multiply those and double them, and then your last term squared. This will be plus or minus depending on that, and this will always be plus. So complex numbers look like binomials, and they're going to follow the same pattern, but just like when we did this with radicals, I want you to write out the expanded step. But not expanded step like foil it. Don't write it as a binomial to itself and foil it. Okay? Just like in the last test, if you write out the expanded formula, you will get full credit. If you expand it and foil it and get it right, you'll get partial credit. Okay? If you want full credit, you need to be following this pattern. So the pattern is, for complex numbers, our binomial is, instead of a plus b, is a plus bi squared. And just like with the radicals, when you expand this out, put everything in parentheses. This matters because the squaring affects what's in parentheses. So we have our first term squared, and then plus or minus, depending on that. This will be plus. And then we have our first term times our second term doubled. So it's 2 times a times bi. And then the last one, because this is a binomial square, is either 2 pluses or 2 minuses. This is always plus. And it's bi. The second term is a bi squared, which means that square belongs to the coefficient and to the I. Okay? That's why the parentheses are important. And of course, a minus bi squared is just our first term squared minus 2 times a times bi, and then always plus bi squared. Okay? So with that pattern in mind, if we take 3 plus 4i and square it, or say 9 minus I, and square it. The first step should be, just like you do this mentally, but you're going to write down that expanded step with the i's in parentheses. So our first term squared, this tells us it's a plus. 2 times our first term times our second term, which is our bi, and then always plus our bi squared. And then simplify each little packet, and you will end up with a complex number. So 2 of these will be able to be combined.
So with i's, the second sign will always be negative then? Because it's I squared.
Yes. Yeah. So I still write it out this way because we're following the same pattern, where the last thing is always positive. But because it's not just a b squared, but a bi squared, that will end up flipping the sign. Yeah. But I write it this way because I want you to see it's the same pattern as we've already been doing with regular numbers, regular terms, and with radicals. Okay? Which is the middle term is plus or minus, depending on this, and the last term is always positive. Once you simplify it, that I squared will flip it. But when you first write down the pattern, it's exactly the same. 2 pluses or 2 minuses make this a plus. Okay? This becomes 9 plus 2 times 3 times 4, I. Plus, now that would be real, this is why we use parentheses, that square goes to the 4 and the I, so plus 16i squared. But, because we have the I squared, cancels out and makes that negative. And now we can combine the first and the last, because those are numbers, but not the middle one. Now be real careful with the second one, because that I doesn't have a coefficient. Here, you had to be careful because the I did have a coefficient, so it had to be squared also. Here, you have to be careful because the I doesn't have a coefficient, which doesn't mean I squared disappears. It becomes
2i. Well, whenever you
Become -1.
becomes -1, right? And if you don't have to write the -1 here, if there's already something there, you just flip the sign. But if there's nothing else there, that doesn't mean it becomes 0 and poof disappears. You have to write the -1 if there's nothing else, because that is what it equals. This is minus because that's minus, but this is always plus. My first term is 9, my second term is I. So I'm just putting in 9 and I. The middle term here was plus and here it's negative because of that. And the last term is always positive because it's either 2 pluses or 2 minuses. Everything's in parentheses. Now this is just I squared, so what does it become?
-1.
Right. There's no coefficient to just flip the sign, so that does not mean it poof disappears. It means you have -1 or plus a -1 or you have to write that. It's not a 0. Okay. If there's nothing else there, you have to physically write the 1, and it's going to be a -1 because it does flip the sign. So of course those combined. Yes.
Don't you have a GCF?
Oh, I mean, at this point, yes. Yeah, I mean, you can actually, you can GCF, and we're going to, in the rest of this unit, there's times where we'll want to do that. But you don't need to do it here. Yeah. Yes, just like a binomial, just like you can distribute, these are like binomials, you can also GCF them like binomials. But you don't, you're not being asked to factor this. Yeah. But good eye, that's going to come in useful for the rest of this unit. Okay, so our last special product is complex conjugates. Okay, so conjugates, A plus B, A minus B. These have cool properties. If you FOIL them out, the middle terms, the O and the I cancel out, and you're left with a difference of squares, A squared minus B squared. Okay. So just to put this all together, so regular conjugates, so if you have A plus B times A minus B. We'll just say with our regular terms like x's and y's, okay? Then if we FOIL that, of course our O and our I are opposites and cancel out. So we just have our first term squared, and then minus, because these are opposite signs, not a binomial squared, one's plus, one's minus, so it has to be a minus, and then B times itself, so that's B squared. Conjugates multiply to make a difference of squares. Okay? So if you FOIL this out, great. If you want full credit, you understand that a complex, that any conjugates multiply to make a difference of squares, and you can show this expanded, and then you're done. And if this were just like numbers, so like I did up here, if you just had like x plus 5 times x minus 5, I want you to be at the point where you're like, oh, conjugates, difference of squares, first term squared minus the last term squared, done. Okay? Just like this with regular x's, I want that pattern to be kind of in your sleep. Okay? But with radicals and with i's, I do want you to write out the expanded step so you don't lose track of what you're doing. I still do expand it out in many cases because I lose track otherwise. So that's with just regular terms like x plus 5, x minus 5. Okay? Now we also looked at conjugates that involve radicals. Either both A and B or one or both of them are radicals. So let's do one.